at least for this module, just forget that you are learning a technology like blockchain or something. Okay, because this is going to be a fun activity, and for that you have to unwind yourself and let your imagination free. Yes, so enough of the hype. Let us go to the module 2. Yeah, I'm sure the moment you see this slide, you will know what this is about. This is the final status of the World Cup Cricket 2011 match between India and Sri Lanka. And this shows what happened at the end, where India won the match after many years. And it was a great moment for us, I'm sure. And the scores show that India has scored more runs than Sri Lanka. Now, even if you do not love the game called cricket, that's fine, as long as you know that this game is decided like whoever scores the most runs wins, that should be fine. Okay. Now, what you're seeing before you, right, is the final status of that match. Now, if anyone is asking you a question like, is this the match all about? Is this the score, entire score? No. You may say there is some more to it, like what the Indian innings was, how much the Indian batsmen scored. Even now, this score is not full unless you see the score that Sri Lankan batsmen scored in the first innings and how did our bowlers bowl, those details, and in this part, how did the Sri Lankan bowlers bowl. So all this makes a scorecard, and still this is only a scorecard. It doesn't make the entire details of a match ready before you. So just think for a moment. This is a hypothesis, right? That's the reason I asked you to actually let your imagination free. And this is a fun activity, right? Imagine there is a very a hardcore fan of Sachin Tendulkar, and he was not happy that Sachin Tendulkar scored only 18 runs in this match. And what he wants to do is he just wants the score of Gautam Gambhir to get reflected as Sachin Tendulkar's score, which means he wants to change Sachin Tendulkar's score as Gautam Gambhir's score, which is 97. Sachin actually scored only 18. And he wants the entire world to believe that. Now, what are all the possibilities for this to happen? Yeah. So before I request you to pause this video, I will also give you some information. See, this happens in a stadium, right? And also, not everyone get to see in the stadium. Many of the cricket fans watch through the television, and few follow the score in the through the mobile or through their laptop, whatever. So this match is being observed by people not from just from the stadium, even outside the stadium. So which means thousands of people are watching. And also this match is being recorded and broadcasted later. Now all this is happening, right? Now after the match, if someone wants to go and change the score, what he could possibly do? Now pause the video for a few minutes and think about it. If you were that person who wants to go and change the score, just swap the scores of Sachin Tendulkar and Gautam Gambhir. What all things you would do so that the world should believe that yes, Sachin scored 97 and Gambhir scored 18. To create such a situation, what you will do? Pause the video for a moment and play again once you're ready with your answers. I'm sure you spent some time on this and you could have thought, what kind of activity is this? But if you think deeper, you will understand how difficult it is to tamper a data if that data is being made transparent and a lot of people have seen what happened as a truth. That's number one. And number two, coming to the case, if I were to go and change the score of Sachin Tendulkar, It is not just enough for me to change or hack the server of International Cricket Council and change the scores. The scores are not just available with ICC, which is International Cricket Council. It is available with thousands of people, in fact, lakhs of people in different forms. In the form of a video of the entire video of the match or in form of a scorecard through the websites. So this one version of data is available in many places. Yeah. So to tamper the data is highly impossible. And even if someone will attempt to do that, he should tamper many data. For example, he should go and tamper the data of the bowlers who bowled to Sachin and Gautam Gambhir and make their record different, because if X bowler bowled Gautam Gambhir 122 balls, we have to change 122 entries of that bowler or bowlers to Sachin Tendulkar. Like this, many changes has to be done, and in fact, you have to go and delete the videos in the entire world that contains and create a visual effects for making sure that Sachin is actually scoring 97. All this. In this hypothesis, we see two things. One is if the data is shared with all the relevant parties. Again, relevant parties. Right data, relevant data is shared with all the appropriate people, then the data becomes very strong. The truth is always being told to the right people, and whatever information is being told in the right manner. And number two, even if someone attempts to change the data, it becomes highly impossible because the way the data is shared is like that, like in this case. Yeah. Now, if you ask, uh, let's say Gautam Gambhir scored 97 runs in this match. This 97 runs, if someone questions, like, I have a doubt if Gautam Gambhir really scored 97 runs. If someone says this may not be true, how do we prove that? Now, pause the video for a second and think about that. How do you prove that some batsmen scored X amount of runs through factual data? Thank you for spending some time on that. In the previous question, it was like, how do you tamper the data, change the data? That was a challenge. And we understood that it is very difficult when the data is actually shared with a lot of people, and not just one source is enough to change, but we have to change a lot of sources of data. And now the question number two is, if someone questions the integrity of the data, in this case, if someone questions like, did Gautam Gambhir really score 97 runs? How would we prove that? For which we have to have the information about the first ball that Gautam Gambhir faced up until the last ball of Gautam Gambhir's innings. So all these runs should add up to 97, which means our data capacity should have all the information about the entire innings of Gautam Gambhir. Like this, any player can be questioned on their performance. In fact, the bowlers also can be questioned. Did this person take the wicket in that ball? Yeah. So it is always better to have a history of information rather than just getting away with all the past and showing what happened in the final, right? So this is one more lesson. So just imagine in a simple scorecard, I'm sure we all have been watching cricket for a very long time and we didn't think in these lines, right? What if something happens in terms of data tampering, and or what if something happens if somebody questions the data integrity, or if it is a honest data entry? Now these are all the things happen. Number one, if the data is shared with the relevant people, the relevant data, again, if it is shared with relevant people, the tampering of data is that much easy, because tampering should happen with all the sources or all the places where the data is present, not just one place. And number two, if anyone is questioning the integrity of data, we must always have the backup data or the history of transactions that led to the current state of the transaction. So this way, we will proceed to the next module. Welcome to the next module. In the previous module, we actually went a little deep inside what a cricket score is and different aspects like on what conditions tampering becomes very difficult for people. And also we discussed about how do we prove that a particular score of a batsman is true, and how does the history of the entries will help in the sense right from the first ball of the batsman that he faced up until the last ball. If all the runs gives a sum of what is the final, then that is what it is. So coming to the next point, what do you think about that book? That is a book, like for example, a dictionary is a book, and a dictionary is a book that contains definitions for the words, right? So in that way, what is that book called that contains the history of every event or the entries or the transactions, and also has the final state of the transactions? And when you see this picture, what comes to your mind? What is that book called as? That begins with the letter L and ends with the letter R, and there is a six-letter word. This is a six-letter word which begins with the letter L and ends with the letter R. Yeah, it may not take much time for you. Of course, it is a ledger, right? So a ledger will have the sum of all the spendings or whatever, depending on the ledger, and also it will have all the previous transactions that were made. Correct. Only then it's a ledger. If the ledger simply says, hey, this is the final figure, no, you may not call that as a ledger because it may not be useful for you in terms of checking where all the spending or earnings happened and all that, right? What if this ledger is distributed, the same copy of ledger is distributed to many people? Then it is called as a distributed ledger. And when we discussed that hypothesis, if someone tries to tamper the cricket score to prove that somebody scored some runs, what happens is it becomes a difficult task because that scorecard is distributed across many locations, many people. And in the same case, a distributed ledger, if the copy is being shared with many people, not just in the final stage, every moment an entry is made in the ledger, everybody gets to know about it, just like a cricket score. How it will be? How it will be, tamper proof. That's the beginning. This moment is the beginning of understanding the very basics of blockchain. Yes, from cricket, we have now jumped directly into blockchain. Welcome. Yeah. Now the word says blockchain. Now let's understand part by part. Now, what is a block? A block contains data, right? Data in forms of many transactions. Not just one, it could be many. And one part of block is data. The other part is a hash value. And it also has another hash value which belongs to the previous block. Okay, so a block contains one or more transactions. That is number one, and it contains a hash for itself and the hash of previous block. Now let's get to the next part. We saw that a block contains data, a hash, and also the hash of previous block. Now what is a hash? Hash function converts data of arbitrary length, in the sense any type of data, to a fixed length. This process is referred to as cryptographic hashing. As you may see in the picture, you will have a long string of data, right, which is like a hexadecimal data, hexadecimal hash, and this could be outcome of a simple name. In case of my name, if I just type Manoj and see what is the hash function of that, you could see a similar one that's coming up. or if you just type hello, you will also get the same. But if you change a single character, maybe from a small to a capital letter, the entire hash value will change. And this is run using an algorithm. In case of blockchain, this hashing mechanism of converting a data into a hash is done through SHA 256 algorithm. And this is a 256-bit algorithm, and this produces a 64-digit hexadecimal number as hash, which is highly difficult for somebody to hack. Now, why we need a hash? What if simply the data is stored and along with a password, just the way we have been, using email with a password? What is the need of having a hash for a block? That is something we will understand in the coming course. Now we just understood about what a block is. We understood a block contains data and there is a hash, and the hash is actually generated by getting all the data, putting inside a hash function. And in this case, we are using a SHA-256 hash function, and we get a hexadecimal, hash. And this is what a block is. And if you have a chain of blocks, okay, where each block is linked to the previous block, that makes a blockchain. So each block will have data, okay, and each block is linked with the previous block, which means if I try to change any data, let's say the orange block, orange color block, which you are seeing before you, if I try to change any data, the hash value of that particular block will change, which means it will affect the next block as well. Imagine you're storing the cricket scores for each and every ball in each and every block here. Not just the score, you're storing every possible information. So blue color block number one, you're actually storing the ball number one bowled in that match, who was the batsman, what was the run scored in that ball, and number two, who was the bowler, what was the time, the date, the location, everything in each and every block for each and every ball. And if I have to tamper that, simply like using a password, it is not possible, because any change in the existing block will affect the next block. So a blockchain is a distributed ledger. You may say a distributed ledger technology that stores information about transactions in a distributed manner in forms of blocks. Yeah. Now, what is distributed ledger technology? Now, I think you were able to link why did we discuss cricket score here and how is that linked with blockchain. A cricket score need not be a blockchain technology, but we just try to get some understanding of conceptual aspects of blockchain. First, distributed technology, it is distributed. Data on the blockchain is replicated across all the places wherever the ledger is seen. And synchronized. Synchronized, what does it mean? Any change made in any source will be reflected in all the other places. So data on the blockchain is replicated, shared, and synchronized among parties on a distributed ledger without the need of a central administrator. Unlike owned and managed databases, which we are using currently, like RDBMS and other databases, blockchain provides an independent data sharing platform. And the next conceptual aspect of blockchain is immutability. It is immutable. This means once the data is entered on the blockchain, it cannot be deleted. Once a block is created in the chain and the hash function is created and it gets linked with the next block, along with getting linked with the previous block, it cannot be deleted, or the information inside the block cannot be changed. So this makes a block immutable and hence the entire blockchain immutable. Edits can be made only by appending new or updated information, which again will become a new block. For example, block 1 says uh, ball number 1 of the match, and a batsman has hit a 6. Yeah, a block is created, and in the sense a score is already entered, but it goes to the third umpire and it seems like it was not a 6, it is actually a boundary because the ball just landed before the boundary line. So what happens is, just to compare with the blockchain scenario, you will not delete that entry, but rather you will say another block that the previous uh, decision of a 6 for that batsman is not valid. Now it is actually a boundary, and this change in the score happened through referring to the third umpire, and the third umpire was this person, and it happened at this time and this date and all that for each and every block. So this means you have a permanent record or audit trail for all the data entered. See how detailed it is when it comes to having the history of record. You know every bit of it in a blockchain, and it is digital. Now you might imagine that if there is a blockchain solution, many people are actually involved in that. No, not necessarily. As we proceed further in this course, you will understand that it is mostly machines that is doing this job. It is digital. This is what I mean. While not unique to blockchain, of course, digital is something used everywhere. It's important to know that all data or processes and transactions or progressively become digital. It should be less of humans and more of machines or devices, which will make some sense for the businesses. Why should we employ or deploy more people to do something while we are actually aiming at reducing cost and increasing efficiency? So this is a lot of digital involved here. So let's have a quick summary of where we have reached. A block contains one or more transactions with a hash value for itself and also the hash value of the previous block. So that's a block. Hashing is a hash function, or hash function you might say. Hash function converts data of arbitrary length in the sense it could be of any length randomly, to a fixed length. Okay, and this hashing function is done through a algorithm called SHA 256 algorithm, which is a 256-bit algorithm, and it produces a 64-digit hexadecimal number as hash. I'm sure you remember that any minute change, any change for that matter, within the data will change the hash value entirely. You may in fact experiment this in websites that are that will show or will generate a hash value for any character using SHA 256 algorithm. You may type your name and check with all small letters what is the hash value, and then you type your name again with one character in capitals and see what is the hash value. You may experiment that. And blockchain, a blockchain is a distributed ledger that stores information about transactions in a distributed manner in the form of a block or series of blocks. And importantly, the blocks are arranged chronologically in the sense block 2 will have data about transactions that happened after the transactions in block 1. It is not randomly arranged. It has some sense the way ball number 2 in a match gets bowled after ball number 1. It is not otherwise. Or ball number 4 doesn't get bowled after ball number 1. It is always 1, 2, 3, 4 that way. It is chronologically arranged. So if you go and trace block by block, it will make some logical sense and also chronological sense. Coming to next, distributed ledger technology. It has data on the blockchain that is replicated, shared, and synchronized. Synchronized is the word you must try to understand again clearly. It is about data getting reflected among all the parties at the same time, not just later. Yeah. Immutability. This means that once data is entered on the blockchain, it cannot be deleted. Edits can be made only by appending new or updated information. With blockchain, you have a permanent record or audit trail of all data entered. imagine a situation, use blockchain for managing your supply chain, and you happen to enter a supplier's information where you got the name wrong. Yeah, and you have to edit it and you have to enter it again. Nothing wrong happens, but what will happen is the fact that on the first entry the name was entered wrongly will be registered in a block, and then you can add always another block that will say that the correct name and in correct order. Yeah. So now we have used cricket as an analogy, and we have understood certain aspect like what is a ledger. Ledger means it has all the transactions. There is nothing important or less important in that. Every transaction is recorded. That is what makes a ledger. And when it is distributed across many parties where every person gets to know or every party gets to know the updates on the same time, then it becomes a distributed ledger. And if it is done through technology, then it is a distributed ledger technology. Yeah. And we also learned about immutability, hashing, hash function, and blockchain with reference to cricket. Now let's get into business from the next module. I think this picture will help you to recall what did I mention in the introduction video, that if you were a customer buying a box of oranges from a departmental store that claims to have a blockchain solution, these are all the privileges you will enjoy. What kind of privileges is that? First, you will get to know the information about the product you're buying. I think as consumers, I think we all use different products in our lives. We use cell phones, we use lots and lots of utilities, television, vegetables, or every single thing that we buy. And each product claims that it has certain features. However, we go by the trust that the things that are mentioned in the packaging are the information that we deserve to know, and those are the details that we can know, not beyond that. However, blockchain solutions gives you a lot more transparency towards every person who is involved in the entire business chain, right from where the product or the service is originated until where it reaches the end user. The relevant parties will get to know what is happening, because this is very necessary so that the end customer, in this case the buyer of the pack of oranges, okay, if he has to buy a good set of oranges, it has to happen with the collaboration or the synergy of many parties, right from the farmer who is actually growing those oranges, and the logistics person, and the person who is actually storing in the warehouse, and then who is again going to transport it to the departmental store, and people in the departmental store who is going to stack it and label it properly, everything, and it should come to you. And as a person who is paying money for that product, you deserve to know, am I paying the real value? Let us take the example of organic oranges, and what kind of information you would love to know or you would prefer to know as a consumer. First, you would love to know, because you're paying an extra money, because these are organic oranges, not the normal oranges, you will get to know if these are actually from an organic farm, right? So as a consumer, you the primary information that you would like to know is where the farm is located, where, when it was actually sent from the farm immediately to the warehouse, and what date versus what date I am buying. So this information will make you believe that the oranges are from an organic farm and it has reached me in the right time, before the oranges are actually getting little rotten, which means you're buying a good quality orange which is of organic type, not of a normal type which is non-organic, which is like hybrid or artificial. Now, for this, you will also require another information. Okay, how do you decide that, the information you're seeing on your, you may see in the picture that, imagine this is your mobile phone, and what else the information? Yes, it is showing some address of a farm from where these oranges have come. Now, if this information is also having that this farm is certified as an organic farm for producing oranges with the license number, imagine your experience as a consumer. You will feel even more delightful. So the delight of a consumer of realizing the full value of money is one of the key offering of blockchain in the case of consumer. And if you are imagining that you are a logistics supplier for the departmental store, like you're the transporter, imagine, you would love to know that what is going to be your next order to pick up from some location and deliver in the departmental store much in advance. And also, if you would like to know if your invoice has been processed for whatever uh, goods that you have delivered to the departmental store much in advance, in what stage it is, and if everything is happening automatically in automated fashion, imagine the kind of energy and time you will be saving as a logistics player in this business chain. There also you have uh, an advantage of having a blockchain solution. So like this, a blockchain doesn't mean that it totally favors the end user and leaves the other people to suffer, but it is for the entire business, which means the end user up until the person who is actually supplying the service, everyone has a benefit out of this, which means everyone finds an efficiency factor in blockchain. So that is something you have to keep this in mind, because enterprise solution, whether this is blockchain or ERP solution, anything, the underlying factor is it should make things better. It should make things a little smart, I mean, smarter than before, where less humans are involved or less time is invested. And the person who was actually doing some kind of work should be doing some matured level of work than what is being done. And you are able to add more value addition to the customer that way. So that's the underlying factor of any technology, and blockchain also, matches to those expectations. It doesn't come here and disturb the ecosystem. It actually brings value to the ecosystem. That's something you must be, absorbing at this stage itself. And the technology, whether it is blockchain or anything, the technology will always remain to be raw, in the sense it will be in a very formless shape, and we have to give shape for that by smart requirements, design, and building the solution above that. And this, again, this logic applies for any technology for that matter, not just blockchain. Even when it comes to data science, or even when you create a machine learning model, for example, you must be very clear about, okay, what is that requirement I'm going to address here, and what business sense it makes at last, whether it reduces time, whether it is reducing effort, and what impact it will bring for the ROI. When the customer or the company is going to invest so much of money on the technology, what is that ROI it's going to bring in terms of profitability, in terms of, you may say, more sales, reduced amount of time to complete a task or a business process in that way. So blockchain, all these questions, it has a clear yes. It definitely makes a lot of business sense. Yeah. Now let us get into this particular example where I'm going to present you this particular case of IBM Food Trust. IBM Food Trust is a offering from IBM. Okay, and as you know, IBM is a very dominant player when it comes to offering blockchain solutions, and IBM Food Trust is a very unique project when it comes to companies that are involved in food business. You may say the companies like Walmart or anybody who is in the business of producing food or selling food or transporting food. So they have a set of solutions using blockchain, and we're going to discuss something about that now. And this is a brief of what IBM Food Trust solution is about. Again, IBM Food Trust is a trademarked name, and this is a solution. You may relate this to IBM, WebSphere or IBM's, cloud offering that way. So this is a blockchain product from IBM, which is customizable, and this has been first implemented for Walmart, which we will discuss in detail in the coming modules. IBM Food Trust creates a secure, shared, and permission record of transactions. This enables unprecedented visibility during each step of food supply chain. IBM Food Trust achieves new levels of trust and transparency, making food safer and smarter from farm to fork, which means from the place it is produced to the table, everything is secure. The people who must make decisions about stopping a shipment of food from the place or understanding if any danger is there in terms of if the food is not handled properly, in case of vegetables, if it is not being transported in the right temperature, imagine all this is being tracked in an automated fashion, and it is being in a maintained in a traceable way. So that's the unique aspect about IBM Food Trust solutions. So all these concepts of immutability, distributed ledger, time and again as we discuss these cases, you should be able to relate how does it come here. So you may pause the video and think, okay, where do I see immutability in this situation? What kind of distributed ledger technology is existing here? What is the distributed nature in this kind of a solution? So time and again you have to pause and ask these questions to yourself, though I will be briefing about you again and again, because this is very important. Fundamentals are very important, and if you're looking yourself in terms of growing fast or being clear in understanding the requirements from your customers and devising a technical design out of that, or architecting a solution out of that, these are all the important factors, because while you compromise on fundamentals, your next part of the journey becomes that much weaker, right? So these are all very important. So time and again you pause and ask yourself, how do I relate whatever concepts I have learned in the previous modules to this? Where do I see those modules, or those concepts coming into the picture in this current case or scenario? Because we will be discussing about Walmart and also Honeywell. So you have to pause and ask yourself, how do I see those concepts being relevant in these cases? Yeah. So in the next module, we will have a deep dive into what the IBM Food Trust product is all about, and we will be learning some critical concepts as well. So IBM has more than 400 clients as on 2020 January, but now I think there will be more clients in different industries, global trade in terms of large scale supply chains. Like I think you could have seen Maersk, which is a very big shipping company, and they do large scale volumes of shipping. And IBM Food Trust is one of segment of blockchain solution, and they have universal payments, or as well as a blockchain solution where they have ClickX. And you will be seeing Marisk, and there is a right side arrow, okay, and you find DuPont, Dove, and in Walmart you find there is a right side arrow, blue color right side arrow, and see Nestle, Kroger, Unilever, and all that. This means that primarily Marisk is the company that takes the help of IBM for creating a blockchain solution for them. However, Marisk is a company that doesn't work as a silo, correct? They have their own suppliers, their own customers. So for them to be successful, they also have to have their suppliers and their customers be part of this technology, which means they should be one of the user of this technology so that it becomes a meaningful aspect of their business. As much as you may see in Swiggy, or you may see in Zomato, these kind of companies, you as a customer, and somebody who's delivering your food as a food delivery person, and also the company, we are all part of this technology ecosystem. We have the app, we have set of relevant aspects that we can access as a Swiggy or Zomato customer, and there is a delivery person who is having an app, and he has set of relevant things that he can go and access as a customer. So we all have to come together, and it should happen in a convincing way where we all have to find a benefit out of that. Otherwise, why would we go and access a technology or subscribe for that, right? So that way, if Marisk is going to be the primary user of this solution, then they have DuPont, Doe, and many other. So this way, IBM has a large set of people who are actually enjoying the benefit of their solutions in different segments. So IBM Food Trust has Walmart as one of the customer, and Walmart being a buyer of Nestle, Kroger, Unilever, and 10 more other major suppliers, they also have agreed to be a part of their blockchain solution, which means they all exchange relevant information in the blockchain way. So anything that Nestle is going to produce and supply to Walmart, the information sharing happens in a way that every bit is being automatically captured, and the relevant people are known without any human intervention, and the information cannot be changed or hampered. And now, as I told you, you may go and relate to the concept of immutability. Why the concept of immutability is highly fundamental in blockchain is because the whole value is around that. Why would somebody go and create a new technology that doesn't have anything special? But here, because of hash function, immutability comes, which means if I have moved a shipment on at 9 o'clock, but if I have to move it to Walmart at 11 o'clock, I can not go and change that. This is, I have actually, I have moved it at 11 o'clock. Okay, so the time and many other aspects, the location from where I'm moving. For example, if I am actually supposed to move the goods from that X location, let's say Hyderabad, and if I'm not moving from Hyderabad, I'm moving the goods from somewhere else, I must not be actually having the right to go and enter the information I wish to enter, because it should be controlled by a GPS location tracker, and that should be fed inside the blockchain automatically, and that should not be in a position to be changed by anyone, because if it is changed, being a hash function oriented technology, the next link gets delinked, and the person who is actually the one of the stakeholder in that blockchain solution ecosystem will get to know about it. So this is how it is. Yeah. Now IBM Food Trust, actually, see, any technology, it has always begun always with some kind of a problem, right? We try to solve the problem. That is a reactive approach, and then we get on to know that, we should continue to, use this approach to add value rather than being reactive to simply solve a problem. Now, that is how it started when there was an issue with some kind of a food infection in a food product in Walmart. They found it very hard to trace which shipment contained that infected product. That took, weeks together, and that's when they realized that we have to find a way to track if anything like this happens, because situations like this, like an infection in the food, could happen, and which is beyond the control. But for us to go and trace it and nail it on the exact issue is very essential, because in this case what happened was, because of one set of infected food, they have to actually uh, destroy all the shipments, and they have to face a huge financial loss because of that. Now, for these kind of situations to be avoided, Walmart decided that, okay, let us go and explore this option, and they piloted and they found it to be true. And they also found another benefit where, when the customers are actually enjoying the benefit of information and the value for money through transparency about from where it has come and who it has produced and what day it has been shipped, what other aspects about the product, everything, it creates customer trust, and hence it creates loyalty. And when there is loyalty, there is more business because customers come back to them, and they make it as a habit to come and visit the place, because trust is the main aspect when it comes to business. When the customer trusts you, that's where the value for money is. They will make it a habit to come back, they will recommend. So the financial success of a business is that much obvious when trust is created. So 2016, in the mid of it, somewhere these issues were found, and they found some way in blockchain to see if this can be piloted as a first project. And they found that it when it took weeks together to find the infected food products origin, when the blockchain was implemented, it took them only few seconds to actually trace, from where it could have come. So this is the power of information in when the information or data is in blockchain. And then they discussed with all the other partners who are actually their suppliers, and they also agreed to that, because they also found a lot of value for them, and their job is also getting much easier in terms of their own requirements. In terms of, for example, if I'm going to be a departmental store owner, and if you're going to be a supplier, what benefits you would be enjoying, when I am recommending you to use my technology, is something very important. Only then you will be using that. For you, it will be like, okay, if I'm going to use this technology, will you inform me about will we inform me in advance about uh, what is going to be my next order, and number two, what is the status of my invoice, when I'm going to get paid for what I deliver. So if these kind of information is being informed to you without a human intervention in an automated fashion, then obviously you would be part of my blockchain network. So the technology design or the solution design is made so smartly that people like Nestle, McLean, Driscoll's, Dole, Unilever, they all have been part of that, and now they have onboarded many other aspects inside their uh, food trust uh, project as well. And this is something we're going to deep dive a little deeper. Now, this slide, you will be coming to know what is happening in reality versus how the information is getting stored in blockchain. Uh, Again, I'm telling you, please learn this from the aspect of creating a blockchain solution. You all can be a blockchain solution creator. For that matter, you all can be creators of a solution, not just blockchain. I would personally suggest you that whenever you learn technology, uh, learn from a creator point of view of a solution. What if you are there, to learn something and create something as a solution for somebody from that angle? So this, uh, from this moment onwards, the rest of the modules will be traveling from that notion of having an example and then seeing technically how this is getting translated into a technical design. That is what you're going to learn. So whatever concepts you have learned, like what is a block, hashing, immutability, distributed ledger, and the next module you will be learning about smart contracts. Everything you must be learning from the creator point of view. You are here to learn the fundamentals of the technology to become a creator of a solution. So in the next module, we will be having a deep dive on this entire chain of potatoes, the journey of a potato, you can say, where the potatoes are being picked and up until it reaches the stores, and the last point where it is getting scanned by the cash person who is actually making the billing for the customer. Till that point, how the entire chain works and how does blockchain comes into picture along with the concepts. So in this case, we will see how a very specific product called a potato is being shipped from a farm to the store and it reaches the customer, and the need for having a blockchain solution here, and what is that unique value addition this brings to the business. And while we analyze this unique aspect, you will also analyze, in the absence of blockchain, what are the uh, features that we will be losing when we use a technology which is not a blockchain technology, like a very normal transaction, where you have app-based, data entry-based, a technology where somebody can actually go and tamper the data, or they can enter the data and it is believed to be true that way, versus a blockchain way of approach, and how this makes a difference to the business. All people involved in the business, I'm saying, not just the customer, but the supplier, the business owner, everyone, right? Now, you will see on the right side, we have used the same uh, diagrammatic or pictorial representation of a blockchain where there are blocks, series of blocks, and each block is chronologically ordered, and each block has a hash value. The hash value is the value that is generated out of a hash function, which is usually SHA-256 algorithm based hash function value. And this has a link to the next block, which means any changes that is made to that particular block will be having a trigger that the next block doesn't have a link. So this is how you will be fundamentally finding that this is actually a blockchain, not simply set of transactions. When it is a blockchain, that this is how it should be, not anything else. It should be immutable and it should be using a very good hash function where each block is protected. Now the potatoes are picked from the farm, and what are the things that will happen? Well, let us have a very imaginative approach. First, if the farmer has to, uh, you know, uh, transport to the transporter, first there are Now the immediate customer for the farmer is the transporter, right? Imagine you and I being the farmer and you being the transporter. I have few information that will be needed from your side, and as a transporter you will need few things from my side. So I will ask, hey, are you the real person to transport these things to the in customer, which is the departmental store? He'll say yes, and he will actually share his ID details that he's the registered transporter, and all this happens through apps. And this is why the blockchain is an approach, and the rest of the things are all the apps that you usually create using your APIs, and there is IoT that is involved. So for the potatoes, you will need as a transporter, you will be needing, if this is being weighed properly, if you are going to if you're supposed to send 100 kgs of potatoes through the transporter, you should actually have 100 kgs of potatoes and not less than that. So your weighing scale, if it has a IoT, it should automatically get connected with the transporter's app, and it registers the information. And as a farmer, you also get to know that he's the registered transporter for the customer. You can trust him and hand over the potatoes to him, and the packaging has all the necessary details about that, and this is how it happens. So every data that is being exchanged gets inside the block, where the block you may call like potatoes handed over to the immediate transporter. The block has all the information about the location where the potatoes has been picked up. For example, if someone has tried a very cheeky idea of not having the potatoes, but he's directing the transporter to go and get the potatoes from some other place. This can be done, if this technology is absent, and if somebody can actually, play around with changing the data. But with this presence of immutability, what will happen is the smart contract, which is written, the business logic or the program that is written above that, will not accept the shipment or or the product unless it is from that particular GPS location, because the farmer's app, the way you are having a Swiggy app, and also the delivery person also having a Swiggy app, the same way in this business chain, the farmer also has an app, and it has its own features that will actually help the transporter's app to receive information about that particular shipment is actually being sent from that point. So this is how this happens. And in addition to the location information, you may also track the kgs of potatoes that is being weighed, and if the weighing scale machine has that much of IoT installed in the machine, then it can send that data also to the block, and that makes a block with set of transactions with a hash value, and that's ready now. That has all the information that the right farmer has approved, handing over the potatoes to the transporter, and the transporter has received, not just the digital signature from the farmer. He has also received other information like the location from where the potatoes has been picked up using the GPS signal, and where the GPS signal of the transporter and the person who is actually transporting the handing over the potatoes is matching. And also the weighing scale data is being stored, and the registration number of the supplier registration number of the farmer and also the transporter is being agreed. Everything happens in few seconds. So this becomes a block, and this cannot be changed. Someone cannot actually hand over 90 kgs of potato and say that I have actually handed over 100 kgs of potato, because there is no human intervention there. It is an IoT which sends information. And next comes the manufacturing plant and distribution center. All this happens, and in each level there are a set of things that few people have to know, the relevant information that few people have to know. Now let us have some role play. All right. Imagine you are a quality inspector of Walmart. You will be, requiring some set of information on a regular basis or real-time basis. Real-time basis, in the sense that you need to have a dashboard that actually shows information about different products being shipped at different stages, and is that being moved and handled in the right manner. So in case of potatoes or vegetables, the temperature at which it is being handled, is the truck being stagnant in a point or a location for a long time, and all that. So for all this, we must not have a human disturbance in the data where somebody goes and changes the reality or the truth and says that no, this is what it is and what you believe is not true. The truth should be based on the information that is being recorded, and it should not be changed. So this is the benefit of the quality manager who would be, willing to know what is happening in the real scenario. And imagine from the point of view of a logistics owner, he would be interested to know, okay, how many trucks are being sent out for Walmart or for this particular departmental store that is on the movement, and is that in the right location to do that, if there is any deviation from what is supposed to be the plan of the route and what is being away from the route, and any discrepancies there, all that can be known to you know to the relevant parties. So the kind of to make for the particular solution in terms of who should know what, okay, and what kind of reports can be generated out of the data, it's all can be done. Again, the important aspect of this is people will come to know the actual data. It is not the data that somebody wishes somebody to know, right? It is what is actually happening, because the data simply cannot be changed. And if something is attempted to change, then there is another block that is getting created, that there is a change or attempt to tamper data in this particular block. So that gives a signal that somebody is not actually adhering to the rules or the policies, or you may also say the agreement that is made between the parties. So in a collaborative environment like this, right from the farmer until the end buyer of the product, uh, each of the person has a dependency on the other person, and they have to enjoy the trust between each other. The trust can be established only through sharing the information, and when the information is not highly human intervened, or very very minimal amount of human intervention, and if that cannot be tampered, and even if reports can be generated, personalized reports, what a distribution center person would be liking in this case would be like, if the store person is going to be scanning each packet of vegetable, and as the scanning is happening, based on the stock that is available, if the distribution center is also getting a trigger, then it makes a lot of sense that yes, this is the actual scenario that is happening on a real-time basis. So you may see there is a ERP as well inside a blockchain approach. So that's why we said SAP is working, SAP HANA is working, or they have already implemented a lot of ERP reporting solutions based on a blockchain solution. So this is not a separate uh, technology or an approach that will be a very isolated aspect out of the rest, but it will actually coexist with the rest. So this is how it happens. So you may see from the beginning of the chain where the farmer is delivering the potatoes up until the scanning point of where the customer pays for the potatoes and buys. Everything is being recorded. Different parties are involved in this. Different people are there, quality managers, distribution center head, the executives. Each of them, they have their own dashboards, they have their own access controls. They all get to know what is happening on a real-time basis with the highest benefit of the data not being tampered. This is blockchain for you in real-time basis. Now we have been seeing, okay, as and when the transactions are happening. Now we have been seeing the example of one vegetable like this. If you imagine a departmental store, it will have thousands of products. Like that, a business will have thousands of lines of transactions. In fact, millions of lines of transactions. So if all these transactions are actually made tamper-proof and it is made real time, and there is a lot of traceability. If something is going wrong, we are able to go and find the root cause of what is that and take corrective actions in a fraction of what it is actually is taking now. Imagine the power of the technology that is blockchain. That's why when we discussed about IBM Food Trust example, I was discussing about it all started with one issue called an infected product for which the traceability took weeks, but after implementing blockchain it took few seconds for them when they piloted and found that this technology has the power, rather than doing a corrective action on that particular supplier. uh, you know it rather than going and disturbing the all suppliers to check if everybody is being not infected. The data gives the visibility about that particular supplier whose product has been infected. So that's the power of that. Now, coming to smart contracts. Now, you may assume that in a blockchain, this is the heart of blockchain. Now, if anyone has to, compare two blockchain solutions and say which one is better, first they would ask, how smart is the smart contract? Now, if you ask what smart contract is a business logic, or you may say on what basis the transaction is being approved, and on what basis the transactions are said valid, or transactions are said to be worth it, like that. Now, these smart contracts are written through computer code, computer programs, and this is very critical in a blockchain. And businesses realize success out of implementing a technology, blockchain technology, depending on how good the smart contract is. So you must understand this concept very clearly. Smart contracts are designed to automate many of the costly and time-consuming processes that slow down businesses down through preset business rules and terms. Imagine if I have to approve a supplier who is a vegetable supplier, I have to have certain conditions that he should be certified. In case of United States, they have USDA certified farmers who are having the right level of quality and in terms of hygiene and maintenance in their farms. And if somebody is organic farmer, then they have their own certificate as well, like this. Uh, Suppliers are decided by the companies based on different criteria, and these kind of checks and verifications can be quickly automated through blockchain, and this happens with less human intervention. And if the smart contract is written and the technologies are available, as we discussed, Linux Foundation's Hyperledger project itself is a project that helps organizations to write smart contracts that will automatically go and verify if the information provided by the party is true. Imagine if I'm going to give you a number that says that I'm an organic farmer, this is my license for having organic farm with the license ID, my GPS location, that will automatically approve that this is a good vendor or this is a good supplier, and this is a really an organic you know product supplier. So this way there are many situations where a smart contract can keep away a human intervention and automate things for the good of business purely based on the merit of the data and information, right? So while we develop a blockchain solution, the smart contract will be of prime importance, because that is going to decide if the blockchain solution is going to be of benefit or if it is not going to be of benefit for the company. It is much like implementing a cloud solution for a company. So there is a cloud solution. However, the way you architect the solution based on the requirements of the company will decide how many virtual machines you create for the organization based on the requirement, and all that will decide if the cloud solution is giving benefit for the organization in terms of security, in terms of managed infrastructure and all that. The same way, a smart contract will decide if a blockchain technology is of benefit for the company. So smart contracts are programs, and let me take you to another part that will give you a better idea of how smart contracts really work. Now imagine there are two parties. In this case, again, we will go to the case of let's say the end customer is party 2, and the person who is actually doing the billing in the counter of the departmental store is party 1. Now there is a there is a smart contract which is actually written at that particular point. A smart contract here, you may read it, which is like a statement. Smart contracts are computer programs that are stored on a blockchain and automatically execute when predetermined terms and conditions are met. Now, if you have to have the right to scan the QPR code of the product and understand where the product has come, first you have to buy the product. So then you have the luxury of enjoying the information about the product. So what happens is the QPR code gets activated once it is scanned by the person who builds the product on which the QPR code is there, and the bill is generated, and quickly a QPR code is activated for you to go and scan, and your mobile phone is also linked with the billing. So this whole logic of interaction between your mobile phone and the QPR code and the billing, all this is defined in the smart contract. So smart contract is the business logic at each and every. So you will find thousands of smart contracts written on different points of a business chain. So while you create a blockchain solution, your predominant time will be spent on how do you design this business logic and convert that into a smart contract. For this, you use Hyperledger or Ethereum, and these smart contracts decide, okay, now I have, now let me go to another example of the farmer and the transporter. Now, the farmer is party one, the transporter is party two, and the transporter sees all the valid information about the farmer through the app. The farmer, the transporter is a human, however, the app collects all the information when it is interacting with the farmer's app, and finds it to be true, and it automatically creates an acceptance a challan or or a document that I am willing to receive this packet of potatoes or few packet of potatoes from you, and that is getting stored in a block, and these are getting stored inside the container or the truck, and the air conditioning machines have an IoT, and that sends signal to uh, the transporters app that this is the temperature at which these vegetables have been stored. So millions of transactions are getting stored in the blocks. Nothing can be changed, and the information that is inside the block are being converted into reports and dashboards. And relevant parties get to know the relevant information. Whoever should know, as I mentioned, if the quality person should know the quality, food quality related information, he gets to know whatever information about the time it took to travel and what is the normal time that is being promised by the transporter, what is the difference, and what is the temperature, many aspects like that. So there are different people, those who are involved here, and all the distinct parties, people, or the group of people, you may all say they're all peers. Okay, they have dependencies on each other. They exchange information between each other. They're not single person. It is all a set of entities that are part of a blockchain solution. And people who are using those entities are people like us, the humans, who enjoy uh, seeing the dashboard and making decisions out of that. What to do next? Which supplier has to be rewarded? Which supplier has to be discussed for on improvement points that he has to improve on these aspects? All that. So a blockchain's power is that uh, the stakeholders in the business chain enjoy the benefit of transparency, and the information is real and it cannot be tampered. So now we saw what a smart contract is. Smart contracts are computer programs. There will be a lot of smart contracts inside a blockchain. Smart contracts are business logics that are programmed using the technologies called Hyperledger and Ethereum, and there are a few other technologies as well. However, for blockchain enterprise blockchain solutions, Hyperledger is dominantly used, and IBM uses Hyperledger. And for the Walmart case, Hyperledger has been used, and this decides at each point of a transaction how a transaction has to be validated, and this will very smartly pick up if there is any effort to tamper the data. So the right people who are adhering to the policies that are set by the company for each transaction will be or could be rewarded, and people who are not doing justice or adhering to the policies, anybody for that matter, can be found, traced, and there can be a very constructive discussion with them about how they can improve their service. So that's the point here. And let us get into the next part of smart contract. Now, I request you to focus on the right side of where do they run. You may ask, so where is a smart contract? Smart contracts runs on company specific nodes in a private channel. Private channel in the sense, imagine as I discussed with you in the previous module, if I'm the end customer of a product from a departmental store and there is a person in the billing counter, now this is a node where a billing happens and I receive the product after buying, after paying for the product. And this is one channel and there is a smart contract. So this smart contract ensures if the money is being paid and if the QPR code B is being activated after the money is being paid, and if the consumer's number is the right number that is updated and he is able to see the information about the product. So this is what a smart contract is. So in a business chain or in a transaction chain in a business, you will have many smart contracts and each node has a smart contract. This is how it is. And if you have to extend this example to the finance department as well, they will have their own smart contract. They will get to know if the invoice raised, if the invoice has been raised by the farmer, because the farmer can raise the invoice if he has handed over his produce or his vegetables to the transporter, and if uh, the information is being found to be true, the information comes to the node called finance, and the finance department will automatically raise a payment request for the person who has supplied that, and the payment happens automatically. So there is a lot of automation that happens because of blockchain, and because the information is being simply trusted, the reason that it cannot be hampered, and the smart contracts are designed so well, there is less of human intervention that has to be done in terms of verification or talking to somebody and seeking approval and all that. It can simply happen on, and this helps organizations to focus on higher level of value additions to their customers. Yeah. Now, this is one sample screenshot of how this traceability works. For example, if you are in the seat of owning the Walmart store, and you have to trace one particular product, and you have to get all the information that is required about the product. We have these many options about that. So you can simply select this, and I mean, you may either enter the product unique ID, or you may select or a range of dates from which you want the product information and all that, and you can get the information about that. So this will all happen on a real-time basis. At different levels, you can set permissions and access options so that it is information without uh, any any level of hierarchy, any level of intermediaries that are involved in this. Yeah, so this is what we have seen so far. So imagine that at each and every point of a transaction, a block is getting created, and that block has all the information that is about the transaction, and that block is approved, checked by a smart contract. A smart contract is a program that is written based on the requirements of the company by people like you who will become blockchain solution creators. And for creating those smart contracts, we use programming languages like Java or Golang, which we'll be discussing later, don't worry. And this is what happens at each and every block. And each and every blocks get created, and the information inside the block is directed to the relevant parties or the relevant report generation points that will create reports, and then it will send to the right people who will want to access those reports and see and make decisions out of that. This is how it happens. And again, remember, these every block, every part of this entire chain of business uh, is immutable and it cannot be changed. And any change that is any change or any attempt that is made to add something, delete something, or update something is again created as a separate block. So if a smart contract is written in a way that if there is an attempt to update any information, it will the smart contract will automatically say that at this particular node called, let's say, a particular supplier, he has actually tried to go and manually enter the GPS information or some other information. So the supplying manager or the buying manager gets to know that this is the supplier who did not adhere to the company's policies, and he can take actions on that. So it all happens in real time. Yeah. Now we did discuss about these words. Now let us see the definition. Peer contains a smart contract and a copy of the ledger. Now a peer is an entity in the blockchain network. Please do not imagine that a peer is a human who is involved or a particular computer that is involved. A peer is an entity in the blockchain and it also has a copy of ledger. Now, a node does not contain a does not contain a smart contract or copy of ledger. It only sends or reads data. If I have to tell an example of peer, the finance department is a peer because it has a smart contract that enables the finance department to send the payment for the supplier based on the information that is being approved based on the smart contract, right? And it also has a copy of the ledger because if the finance department has to get the history of transactions, then it should have access to the ledger. So it has a copy of the ledger. But a node, for example, an IoT device that is connected to the API or the application, let's imagine the weighing scale example or the GPS locator. This is a node that simply sends or reads data. That's all. It does not contain a smart contract. It simply sends the data, right? So a peer is an entity and node is also an entity, but the meaning differs based on whether there is a smart contract in that node or not, and whether it has access to the copy of the ledger, right? And so far in this entire course till now, we have been discussing only on permissioned blockchains, and these are not permissionless blockchains. Uh, if in the case of bitcoins and other cryptocurrencies, it is all permissionless blockchains, which means anybody can be part of that. But as the scope of this course is not about bitcoins, we are not discussing. But for the sake of knowing the concept of permissioned blockchain as a terminology, you have to know that. If somebody is going to ask you, is enterprise, blockchain permissionless or permissioned? This is a permissioned blockchain because you give certain amount of access to certain amount of people, and these access should be relevant to them, and that is how it is. So if you read the explanation, permission blockchain or blockchain networks that require access to be part of. In these blockchain types, a control layer runs on top of blockchain that governs the actions performed by allowed participants and not by everybody. If somebody should go and access, for example, if a supplier has to go and access his record of payments received from his customer, then he should be first of all part of the network, where he should be allowed to see the data, not by simply having an app which is he can download, or he can simply copy an exe file and have it on the computer, but he should have the permission for that. So that is how a permissioned blockchain works. Now we will look at a blockchain implementation in a very interesting industry, that is the aerospace industry. And for this, we have taken Honeywell Aerospace's online used aircraft parts marketplace as an example, where they have used Hyperledger Fabric for development of the solution, and they have successfully implemented for their business, and they have found the results as well. And let us look into that. Yeah, so the introduction is not necessary much for a company like Honeywell, because uh, they are very dominant players when it comes to technology, and in the space of aerospace, they are even more stronger, because they are the ones who design systems for different control devices, and as engineers and the technical community, you must be knowing about that. However, this is a very old company, started in 1914, and they are global provider of avionics, engines, systems, and services, which means they design, manufacture, and also service through many partners, and as well by themselves. And their products, you may say, you take any aircraft in this world, you will find at least one product or a technology of Honeywell, developed by Honeywell in this. So 2018 sales alone is 12.9 million, $9 billion. So which is a huge, uh, uh, business. I mean, or the market they have captured, you may say. And through this blockchain implementation, what they wanted to create is they want to create Amazon.com or Flipkart or such types, these kind of a marketplace for used aircraft parts. So, as we begin to discuss in detail about this case, please keep this in mind that the nature of business that is here. See, aircraft parts are already uh, critical, in the sense you may not say a part in the aircraft is more important or less important. Given the kind of usage the aircraft equipment has got, and the place where it is used, and the criticality in terms of uh, safety and other aspects, every aircraft is critical, every aircraft part is critical. So when Honeywell is involved in selling used aircraft parts, imagine the kind of information that it has to provide the consumers, or the potential customers, you may say. Now, the people who are actually buying the aircraft parts are themselves who will be using aircrafts, and they will have to analyze through a lot of data, and they will expect a lot of transparency in data, and this process of supplying the customers with information for them to make the decision faster. The way you could have seen in Amazon.com, when you want to buy a book, you have all the information, like the people who, the feedback or reviews of people who have read the book already, the details of the author, and a synopsis or samples of few pages of the book, and all that. So that is helping you to make the decision. In this case of used aircraft parts, it will require a different set of information, like in which aircraft the part was used, and when was the part dismantled, and many things. So they want to create such an environment. So that's the goal for them, and they want to cut down the purchasing time, which means the time for a person to make a decision or a company to make a decision to buy a used aircraft part should come down from days or weeks to seconds. So all the human intervention to go and conduct a presentation, and also keep this in mind that these aircraft parts are generally, expensive, materials, which means per unit cost of a material will be in few $1,000s minimum. So the selling effort from the side of Honeywell will be that much high, and there will be human intervention that was involved. However, to convey all the information to somebody who wants to buy, all this is being now avoided by implementation of blockchain. Yeah, and the other goal was to connect to each part of to each physical part to its digital pedigree. Pedigree means the history of the part, who made the part, where it was used, when it was repaired, and when it has been brought to Honeywell Aerospace's online marketplace. This way. So the approach was blockchain, and you may go through the specific points. Maybe you can pause and read. Now, look at the results part. $4 million in sales through an online marketplace, that too for critical parts that takes a lot of time to make the selling, or rather the decision making to buy the part takes a lot of time, has been made simpler through blockchain, and now 4 million in sales is made in less than a year, and more than 50 vendors who are supplying used aircraft parts have become part of this blockchain solution now, which means they feed information by being a partner of the blockchain technology or being part of blockchain network, and that information is used to empower the customers with information so that they make the decision faster. So this is how it works, and the purchase time also reduced, obviously, because the purchasing is a decision, and that decision is made based on the information availability and the quality of information. And when the information is available, and if that is of high quality, then the decision is obviously made quicker. So the purchase time obviously gets reduced. Future boost to anti-counterfeit measures. This is also ensured through the immutability features, because if there is any effort to tamper the information or provide wrong information, it doesn't happen, because the solution is built in such a way that the system, the blockchain network itself, will demand for the smart contract, rather, will demand for information not by the entry form. It will rather demand by information in the form of credible documents that will get again referred in multiple sources and then gets confirmed. So every part is being brought to Honeywell Aerospace's online marketplace using non-human intervention methods. So this is how the this particular case works in terms of technology. So if you come from the bottom left, uh, you look at this dismantlement event where you find this aircraft symbol or aeroplane symbol. The first thing that happens for a used aircraft is that the aircraft gets dismantled. It gets separated into different parts, and that gets recorded in the blockchain. And how this gets recorded, it is recorded based on many factors. The maybe if Honeywell has implemented that the block will contain the engineer or the team that was involved with all the details with their sign off about what time they have started this dismantling event, along with the dismantling event plan as a document, everything getting stored in the block. This gets stored, which means you have so much information, or as a customer, they can go and access so much of information to decide the purchasing aspect. And then comes the OEM birth event. OEM, this the original equipment manufacturer birth event, and this is also recorded based on the history of events, repair and overhaul. If the part is removed and if the part is put through any repairs for making it ready for reusage, then who does the repair, what time it has happened, in what location it has happened, all that gets recorded. And then all this becomes as past history of events, and a list of events are getting created, and then it goes to the Go Direct Trade storefronts. So Go Direct Trade is the brand name of Honeywell Aerospace's used aircraft business. So Go Direct Trade is an online web platform which you may also go and check for yourself, and you will find many aircraft parts being sold. And maybe if you are able to sign in, you will understand that the unit price of those parts are very high. It is in few $1,000s, sometimes in millions as well. So all this information is getting recorded in the blockchain, and the best advantage here by having a blockchain's technology is there is less of human intervention to go obtain information for each of the stages of these events and then feed into a computer, and again to avoid the aspect of tampering the data or giving the data someone who is not really giving the right information. All these issues can be avoided by blockchain, because the smart contract will ensure that the right person is giving the data and the right data is received, and it is verifiable at any point of time later. So everyone has that feeling of accountability who plays a role in this blockchain network, that they will be questioned in the future for this particular issue if they feel that it is not to be of right value, or they did not play as per the policies of the game or the business. So they so the adherence part in a business transaction is very, very high. So this becomes very critical, as I told you again. The aircraft parts business, or any business to do with aircraft, is put under the lens from a technical point of view, and there is a lot of information that is required. It is we must never prefer to have a weak aircraft part in an aircraft, because it will cost lives. So it is of that nature. It is not like books, or it is not like gadgets. So it is very critical. So the value addition of blockchain for the business is very high in this case. And next we will see the case of Walmart specifically, and we will not get into the basics of that, because through IBM Food Trust project we have already seen what is that it is doing for businesses in the supply chain and food industry. But we will go specifically into the results they have actually seen. Now let's look at Walmart case, where they have implemented the solution for tracing their food and its provenance. Provenance means the history of where the food has been produced, and with all the specific information. And this is very critical in the case of food industry or people who are involved in selling consumable foods. As ourselves, I mean, as we people who are consuming food, we will be keen to know, from where my food is coming. And if you're from the point of view of the selling food, you will be interested to know from where the food is coming. If there is any issue, you want to zero in on the actual supplier who has supplied the food and then take some corrective action. So from that point of view. So the issue started when there was an outbreak of an infection, and they could not take a very precise action on a specific supplier of of the location where the infected food has come. So they found that there is a need for a technology or an approach to trace the infected food. So that was the beginning for them to run a pilot, and they did a pilot or a model implementation of the technology through implementing this on a set of one product called mangoes, and they found the results were amazing, drastic. That the traceability of mangoes before implementing the technology was 2 weeks, and after implementing the technology, it was only 2.2 seconds. And this is the primary, what to say, the objective or the feature also, you may say, of blockchain, that traceability is that much easy. As much as blockchain offers the feature called immutability, where somebody cannot go and change the data, and it and even if someone attempts to change the data, the relevant parties will get to know about it. This aspect is another critical aspect. And if you are going to create blockchain solutions for your customer, this has to be taken care in terms of designing the solution. Yeah. And in case of Walmart, these products, you may see that these are all the primary products that are being sold in any departmental store or any hypermarket or supermarket like Walmart. So these products and its suppliers are now partners of the blockchain network of Walmart in the US. And this is the timeline, what happened and where they are now. From the late 2016, Walmart announced proof of concepts. They already had proof of concepts. Proof of concepts means something that can be shown as a future real-time solution by doing pilots, and it is being proven that it will work on scale and it will work on also quality, both terms. So they've got proof of concepts, and by 2017 August, in 10 months or something, they have already brought Nestle, Unilever, and all the suppliers who are under the bracket of uh, food and consumables under their blockchain network. And by September 2018, so all this happened in between 2 years or less than that. So now by 2018, 25 products is being able to traced by Walmart for its history, the location, and all the other information whichever is required to make decisions. So this is the beauty of blockchain, and now we are in 2020, and I'm sure there will be more things into the RKT where they're able to trace more and more products, and more customers are actually enjoying the benefit of being informed, consumers. Now, let's do a quick recap on what the concepts that we have learned in this course is. I suggest again, these fundamentals are very necessary, and it will play a big role when you go into the higher levels of solution creation, or or even coding, because you have to ask yourself the question again and again on these aspects. If the coding or the technology creation process that we are doing, is that adhering to this? Because if imagine if the solution that you are creating doesn't have an immutability feature, then it doesn't add any value, or it doesn't claim to be called as blockchain. So for that purpose, this is very critical for you to understand these concepts. So please pay a lot of attention now, or you may also do more reading on this. Yeah. So a block contains one or more transactions with a hash for itself and the hash value of previous block. So this has a link with immutability, and how the hashing happens is hash functions. You may call this hash as an address of a block, and a block has the address of the previous block as well. Yeah. So this hash function converts address of arbitrary length, of any length. Arbitrary means of any random size, okay, to a fixed length. What length is? It's a 64-digit length using the algorithm called SHA-256 algorithm. And a blockchain is a distributed ledger. You may link this with the example of a cricket scorecard that we discussed. It's a distributed ledger. It has its copy. The copies are available in different node peers that are in the entire network, and this is why this is a peer-to-peer network. Yeah, and this is not like a client-server model. This is a peer-to-peer network, and the relevant permissions are given to relevant people to access relevant data and check for themselves. This is a distributed ledger technology. Data on the blockchain is replicated, shared, and synchronized, and among parties on a distributed ledger. So synchronization is primarily when the data is, there is any change in the data, the ledger gets updated automatically, and the reports or the analytics that the parties are going to see will have the updated information there, rather than somebody going and asking for the recent updated information. The technology itself enables the people who are part of network to go and enjoy the analytics or reports of updated information. Smart contracts or computer programs that are stored on a block, and this gets executed when the predetermined terms and conditions are met. I think we discussed about this. A smart contract is a computer program that will decide as simple as like generate the bill once the credit card or the money is being paid by the customer. So this way, this could be a very simple example. However, a smart contract is written with lots and lots of logics and lots and lots of features inside. Yeah, and a peer is an entity in blockchain that contains smart contract and a copy of ledger. And the node does not contain a smart contract or copy of ledger. It only sends or reads data. For example, a node is like an IoT enabled device that is used in the blockchain network for sending or reading information, and that's it. However, a peer is an entity in the blockchain network. It need not be a human, but it is an entity in the blockchain network that contains smart contract and a copy of ledger. And what we have discussed so far in this entire course is all permissioned blockchain. And we did not discuss about Bitcoin or any other types of cryptocurrencies, but we have only discussed about permission blockchain. All enterprise business blockchains are permission blockchains. Someone will require permission from the blockchain network owner to come and be part of that, of some nature of role, some responsibility. Yeah. And provenance is a term that is used that talks about information about the origin or place of production, the history of data. You pick any data, or if you like to know the history of transaction, you will be able to have that. So that nature of having the history of transaction is provenance. Yeah. So coming to the question of analyzing the opportunity in a situation or a scenario for a blockchain solution, you may consider these aspects and see if majority of these aspects are there in a situation or in a business scenario. You may definitely look for a blockchain solution there. And this is from PricewaterhouseCoopers, and they have found a pattern among all the blockchain solutions and found to be that there are these aspects among all the solutions. Now, first, if the scenario is having multi-party sharing data and multi-parties updating data, if there is a requirement for verification, and if there is a requirement for intermediaries adding complexity, intermediaries in the sense somebody who has to go and or a human intervention where there is to go and approve something, validate something. Interactions are time sensitive, where something cannot take a lot of time. It should happen quickly, so that uh, the uh, the efficiency is better and the customer value realization becomes faster, and the transactions interact with each other. If the situation is having all or the majority of these aspects, definitely there is an opportunity for a blockchain approach in that. So this is the thing that you should have in the mind. And if you look at most of the scenarios, these are like that. And even in case of insurance approval, let's say if you happen to have a damage in your car, and if it requires a police verification, and if the police verification should capture the data of your location, and then it goes to the approval, automatic approval, that yes, this happened here, and this is the officer who actually has verified that this is the car that happened to have the damage, and then it goes to the service company that does the uh, service of the car, and also to the insurance company. So you will find multi parties are sharing data, multi parties are updating data, and there is requirement for verification, and there is intermediaries as well. People who are there that are involved, they should simply go and say yes. So now these intermediaries are primarily replaced by smart contracts and also verification, but the smart contracts will make the job of the end beneficiary much easier, because the intermediary's role will be less biased or no bias at all, because the smart contracts are written in that way. Yeah. And the interactions are time sensitive, when it takes months together to get the insurance cover or the reimbursement for the damage. If all this is going to happen through a blockchain solution, it could happen simply within few seconds. You don't have to spend money and then go and claim it back from the insurance, but it can happen quite easily within few minutes. So these are all the few situations. I suggest you go and read more and more cases and try to relate with these aspects, and you will find that whatever cases or business cases beyond what we discussed in this course will comply with all the points that are mentioned in this slide, these 6 points or at least 5 points which are mentioned in this slide, because uh, most of the business transactions will have such a situation. Yeah. Now, coming to the technology or the tools part, if I have to say, these are all the tools that are used, which you may go and read further. However, in the next course, I'll be focusing on Hyperledger because Hyperledger is used most of the enterprise blockchain solutions for not for cryptocurrency purposes, for non-cryptocurrency purposes are all created using Hyperledger model, and Hyperledger has a bouquet of offerings for different purposes, for storage, for security, for and there is a development environment as well. And each of this Ethereum, Hyperledger, R3, Corda, Ripple, Quorum, each of them they have their own unique aspects when it comes to enterprise needs. However, the cases that we discussed, which are widely used business scenarios or cases, widely used business scenarios as cases, will have Hyperledger as the development platform. Yeah. Now, if you look at how many is using from the cloud point of view, because uh, the technology could be one. However, uh, whether this is stored in an using the physical machine server in your uh, place, or whether it is cloud these days, it is more of cloud or hybrid, because that ensures more data security, and also this is less of effort in terms of data integrity and maintenance, because that will be a lot managed services, in the sense the data management part will be more of use based, or you will subscribe only for what you need. So cloud has become more like a mandate these days. So when you look at AWS, they have almost covered 96.3% of all blockchain features that are there. And you might be asking then, IBM Cloud also has IBM also has a cloud platform. Then how do they support organizations that uses AWS? However, IBM's uh, blockchain solutions doesn't limit only to IBM Cloud users. It also supports the users that use AWS as well. So that's how it is. So the numbers here, it simply says how much the cloud solutions that are from AWS, IBM, or these things has more blockchain solutions. So AWS has 96.3% of blockchain features that are there. So there is very limited, aspects that has to be developed and plugged in inside the cloud. So this is about that. I would like to quickly give you few things that you will have to go and do as activities for the next few days. Is first read a lot of business use cases and try to relate with whatever points that we discussed and the concepts that we discussed. And you should not be confusing between the cryptocurrency or the Bitcoin world versus the other world. That is a different aspect that has, yeah, that uses blockchain, but once you focus on uh, these use cases which are not dealing with crypto money or cryptocurrencies, then you should only focus on this. And if you're going to focus on that, you please focus on that. That will have a different set of skill sets altogether, and it will have something called as you know Byzantine fault tolerance and different concepts like that. So when you focus on this, you please focus on this, and it is mostly like kind of a warning to you that you will get confused. Then if what is that, what is this, but they both remain to be blockchain, but the approach is different there. Okay, so if you're going to focus on Bitcoin, then you please go and do a reading on Bitcoin. But when you focus on this, you please focus on the concepts that we discussed in this course and see how this is getting applied in each and every case and what is the business value add. And you also compare with a situation where, in the absence of a blockchain, what will be the loss or a loss of efficiency or loss of time and increase in effort, all these aspects. So then you get totally convinced that yes, uh, I mean, if you become a smart contract programmer tomorrow, you get convinced that yes, the smart contract that I'm writing for this particular peer is proving to be making things better. So that's where you become a better, a blockchain solution creator. But however, learning the language, through Hyperledger, because Hyperledger uses Java, that is another language called Go. Now, these are all high-level languages, and if you have any basic language, programming language knowledge, it should be easy for you. However, the purpose of writing a smart contract or writing a piece of code should help the business to realize more potential. So, from that point of view, you must learn the fundamentals very strong. And if you require to redo or revisit the modules again, please do that. But when you write a code or a smart contract in the future, or even you architect a blockchain solution, you please make sure that it is making things better, and it is actually not compromising with the fundamentals of the blockchain that we discussed so far. Yeah. Wish you all the best.